So an airplane is going from LA to New York, which is 3,000 miles away. And again, I'm assuming it is. I don't know, but I'm just saying. Let's say New York is 3,000 miles away from LA, and New York is 42 degrees north of east from LA. Okay? The wind exists. I'm going to assume the same continual wind exists throughout the journey. So wind exists, that is 80 miles an hour. That's pretty fast wind. At 22 degrees east of south. So let's say wind exists at 80 miles an hour at 22 degrees east of south. We can ask a couple questions here. If the plane wants to make the trip in 5 hours, what should the airspeed of the plane be, and what should the direction of the plane be? What should the airspeed and direction of the plane be? And then part B. So in the first part, we know that the plane wants to head that way, wants to go towards New York, wants to get there in 5 hours. What should he set the airspeed? What should the pilot set the airspeed and direction? In the second part, we want to ask something like this. What if the pilot forgets to account for the wind? Where will the plane end up in 5 hours? We can ask a question like that. Where will the plane end up in 5 hours if the pilot forgets to account for the wind? Where will the plane end up in 5 hours if the pilot forgets to account for the wind? So let's do part A first. In part A, okay, something like this. You got LA, you got New York. So in this case, you're headed towards New York, and you're going to make a correction in the air. You're going to make a correction for the fact that there is wind, right? So you're going to head towards, the wind is 22 degrees east of south. So you're going to go something like this. Velocity of airplane with respect to wind. That's what I'm going to call that. Velocity of airplane with respect to wind. So that's your velocity in the air, okay? The wind is going to take you down 22 degrees east of south, velocity of wind with respect to ground, and then you're going to end up velocity of airplane with respect to ground. So velocity of airplane with respect to ground is going to equal to the sum of the two vectors. Velocity of airplane with respect to wind plus velocity of wind with respect to ground. Notice the two subscripts are the same. So the velocity of airplane with respect to ground, that's also called your effective velocity because it tells you where you end up at the end. Okay, effective. And that's it. Now we break this up into two components. Velocity of airplane with respect to ground x direction And then we also have the y component. We'll deal with that later. The velocity of airplane with respect to ground. Okay, now we know the distance between the two cities is 3,000 miles, and we want to make the trip in 5 hours. So that will give us the magnitude of this. The magnitude of this is equal to 3,000 miles divided by 5 hours. 600 miles per hour. Okay, so we know your effective speed should be 600 miles an hour because you're covering a distance of 3,000 in 5 hours. So that one gives you this VAG. Now to do the x component, you take 600 times, in the problem gave us the angle of New York is 42 degrees north of east, so that's this angle, 42 degrees north of east. Then New York is 42 degrees right here. So we take the cosine of that angle. So VAG is 600 cosine of 42. Okay. And then this one is VAWX. This one we don't know. We got to solve for that. Okay. And then VWGX. VWGX is the x component of this guy right here. Now, what do we know about the wind? We know the wind, the magnitude is 80, and the angle is 22 degrees east of south. So that would be this angle right here. Right here, this is 22 degrees east of south, right? So east is this way. So what is its true angle here? We could get this angle, 270 plus 22, 292, right? So this whole thing will be 292. So VWG X is going to equal, its magnitude is 80 times cosine of 292. Okay? Then you take this, put it on this side, and you calculate VAWX. Okay? And then you do the same with the Y. You could take the Y component. This one will be 600 sine of 42. VAWY, we don't know. This one is 80 sine of 292. And then again, you take this to the other side, you solve for VAWY. So tell me what you get there for VAWX. Miles per hour, and then Y. Point.